then there is enjoyment to teach. If I keep on teaching, you'll keep on writing, but no revision. What is the this second time revision? Each and every sum I'm doing, even if it is repeated, I'm doing again. Define electric dipole moment. It is defined as the product of a charge, product of magnitude of a charge forming electric dipole and finite distance between them. That is P equals to Q into 2A. Second part they are telling, is it scalar or vector quantity? It is a vector
Vector.
quantity. From where to where directed?
Negative to positive.
Directed from negative to positive charge. Write this much, then I am doing next part. It is defined as product of magnitude of a charge forming electric dipole and finite distance between them. That is P equals to Q into 2A. It is a vector quantity directed from negative charge to positive charge. Next part is given, deduce expression for electric field at a point on the equatorial plane of an electric dipole. Can I clear the screen wala part? Hello?
Yes, sir.
Okay. Now derive expression for electric dipole, electric field intensity on equatorial plane. So this is negative charge, this is positive charge, this is center, these two are equal to A. Here is point P on the equator, that means on bisector you want intensity. So for positive charge, intensity will be outward, let it be E1. For negative charge, inward, E2. This angle is theta, this angle is theta. This is root of r square plus a square. You can call this as B, this as A. Same is this length, root of r square plus a square. Draw one ray. This is theta, means this is theta. So I can resolve E2 as E2 cos theta, here E2 sin theta. Same way for E1, this is again theta, corresponding angle. So E1 sin theta, here also again E1 cos theta. Please draw the diagram. Sakshi, you have followed now?
Kind of, sir.
Kind of means what? Again, shall I explain?
The diagram only, sir.
Okay, diagram once again. Don't say kind of here. Again, I'm explaining. I'm clearing. Okay. See, electric dipole means negative charge, positive charge separated by finite distance. Let O be the center. This is OA equals to OB, which will be AA. P is the point on perpendicular bisector, that means equator. Let P be a point at a distance R from center O on the equator. Join AP and PB. AP is same as PB, which is root of R square plus A square. Root of R square plus A square. Angle PBA is equals to angle PAB equals to theta. Intensity at point P due to positive charge will be directed outward. So this is E1. Now draw one ray here. This is theta. So E1 can be resolved into two components, E1 sine theta, E1 cos theta. Similarly, intensity due to negative charge will be E2. This is theta. So this is E2 sine theta. Here it is E2 cos theta. Now diagram followed. Now diagram you have followed. Hello?
Yes, sir.
Okay, everybody is followed.
Yes, sir.
Lakshya, you have followed diagram?
Yes, sir.
Okay. Now all of you draw this diagram. Then we are writing value. E1 will be KQ upon root of R square plus A square, the whole square. This one also you wrote E1 formula, E2 formula, then E1, E2 are resolved into two rectangular components.
Yes, sir.
Okay.
Wait, sir.
Waiting.
Done, sir.
Can be resolved into two rectangular components. Vertical components are equal and opposite. Hence, they cancel each other. Therefore, resultant EMF, E will be E1 cos theta plus E2 cos theta. Therefore, E is E1 cos theta plus E1 cos theta, because E1, E2 were same values. So therefore, E will become 2 E1 cos theta. Yes, written full.
Yes, sir.
So E equals to 2 times KQ upon R square plus A square into cos theta. Cos theta is adjacent side A upon hypotenuse root of A square plus E square. So I can write 2 times KQ into A upon R square plus A square raised to 3 by 2 for short dipole. R is greater than, very large than A, therefore A square can be neglected. So E equals to K into 2A into Q upon R square raised to 3 by 2. But 2AQ equals to P. So E equals to KP upon R cube. In vector form, E bar will be minus of Kp bar upon R cube, because E bar is this way and P bar is from negative to positive. Therefore, they are negative of each other. This followed in vector form. E bar equal to minus K P bar upon R cube. Hello?
Yes, sir.
Yeah. So can you tell me what will be angle between dipole moment and E at equator? 180 degree. Angle between dipole moment and E at equator is 180 degree because they are oppositely directed. All of you have followed this theory till this?
Yes, sir.
Complete now, full till end. Can I clear this now?
Yes, sir.
Next question number 37. An electric dipole is kept in a uniform electric field. An electric dipole is kept in a uniform electric field. Derive expression for the net torque acting on it and write its direction. Write its direction means clockwise positive, anti-clockwise negative. Clockwise negative, anti-clockwise positive. State the condition. State the condition under which the dipole is in first stable equilibrium, Second, unstable equilibrium. Now, how many of you know this? I'm not talking exactly word to word, but if you feel that, okay, no, sir, after looking at the notes, we'll be able to do on our own, then I can skip this. Already I've discussed with you all these questions.
Sir.
Yes, sir.
What is torque formula you will get? You will get P E sine theta. If the sense of rotation is clockwise, then it is negative. Anti-clockwise, then positive. So you can write this one.
Yes, sir.
What is stable equilibrium? Condition under stable equilibrium: when the dipole is in the direction of dipole moment P bar is in the direction of field, that is theta 0, then stable
0 degree.
Theta is 180, then unstable equilibrium. So you can manage this. Hello?
Yes, sir.
So I'm not doing this. Next, I'm going to the next question. But please, today only you write once in your book answer of this. And still, if you find difficulty, tell me. I will again do on the screen. 38. Sketch the pattern. Sketch the pattern of electric field lines due to. Sketch the pattern of electric field lines due to. First, a conducting sphere having negative charge on it. Second, an electric dipole. Sketch the pattern of field line on due to conducting sphere having negative charge. So this is sphere having negative charge, and the second is what is? So if this is negatively charged, so this is inward, 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 inward. This also inward, inward. Followed, I think now. Sphere radially inward. Hello? हेलो
Yes, sir.
ये फर्स्ट वाला हो गया. अब सेकंड वाला लोग बोल रहे हैं इलेक्ट्रिक डाइपोल. इलेक्ट्रिक डाइपोल मींस if I consider this as negative charge, this as positive charge, so electric inward, positive outward, and then this way, correct? Hello? Draw.
Answer.
59. These are 5 marks question. First one is derive an expression for the electric field at any point on the equatorial line of an electric dipole. Derive an expression for electric field at any point on equatorial line of electric dipole. This so you can do. Just now I did. Correct now? Hello?
Yeah.
This is
Yes, sir.
repeated one. Next is two identical point charge. Two identical point charge Q. Each are kept 2 meter apart in air. Two identical point charge Q each are kept 2 meter apart in air. A third charge Q of unknown magnitude and sign, charge Q of unknown magnitude and sign is placed on line joining the charge such that the system remains in equilibrium. Find position and nature of charge. Find position and nature of charge. If you have written question, then I am solving this. Same sum can be asked even in MCQ. Question you have written?
Yes, sir.
Okay. Two identical point charge Q each are kept 2 meter apart. 2 point charge Q each are kept 2 meter apart. Third charge Q of unknown magnitude is placed on the line joining charge such that system is in equilibrium. Find the position and nature of charge. So let it be placed at distance r, so that this distance will be 2 minus r. Hello?
Yes, sir.
Now system means in equilibrium means everywhere net force should be 0. So if I consider this as first charge, this as second charge, this as third charge, force acting on first charge due to third will be outward. Correct now? Repulsive force. Hello?
Yes, sir.
Which Q wala has to be attractive. Then only there will be cancellation at Q. When it will be attractive? When Q is negative?
Negative charge.
So Q should be negative. Then only it will be opposite. So I got nature, Q is negative. Also, magnitude of F13 should be F12. So F13 is 1 upon 4 pi epsilon naught. Q into Q upon R square. 1, 2, 3 is R. was 2 in fact, 2 square. And this is 1 2 will be q into q into q upon r square. 1 upon 4 pi, 1 upon 4 pi I can cancel. So q upon 4 equals to capital Q upon r square. So capital Q is q upon q r square by 4. Now if I get r, I get the value. Hello?
Yes, sir.
Again, see here. 1 minute. Just see here. 1 second. This is q. This is q. Somewhere is q. Suppose it is r. This is 2 minus r. So if you take first charge, you take second charge, you take third charge, this direction will be this plus and minus. This will be attractive in nature. This negative will get attracted, and this will be getting attracted like this. So force acting on 2 due to first is same as force acting on 2 due to third, which is nothing but 1 upon 4 pi epsilon QQ upon r square is equals to 1 upon 4 pi epsilon again QQ 2 minus r the whole square. So to get position, I am taking center wala point. So 1 upon 4 pi epsilon q into q will get cancelled. We get r square should be 2 minus r square. So r must be 2 minus r. 2r equals to 2. R equals to 1. That means q should be at distance 1 meter from q. Q should be at distance 1 meter from q. Now its magnitude. This much you followed, I think, na? Because you want two things, position as well as magnitude. Hello?
Sir.
So they are asking where the q should be placed. It should be placed at distance 1 meter from q. And for magnitude, F 1 3. See, if you take 2 2, everything gets cancelled, you get r. Now after getting r, we want to keep the q. That means we want this 2. So I can take 1 3 ka magnitude is 1 2 ka magnitude. 1 3 is 1 upon 4 pi epsilon q into q. Distance is 2 square. And 1 2 is 1 upon 4 pi epsilon naught q into small q. Distance we got 1 square. So this 1 upon 4 pi epsilon 1q cancel. So it becomes q upon 4 equals to capital Q by 1. Therefore q is equals to minus q by 4. And distance is 1 meter. Now solve for very important difficult one. This was difficult sum and important because we cannot understand that. First we have to find r. If you're done, then tell.
Done, sir.
Okay. 40. Again, there are two questions. I think first one we have done. Derive an expression. Derive an expression for the electric field E due to dipole of length 12 at a point at distance r from center on the axis. This we have already done. You can do on your own now after referring the notes. Hello.
Yes, sir.
Second part is draw graph of E versus R if R is very large than L. So what we got E here, K into 2P upon R
2p
cube.
upon r cube.
So they're telling what will be the graph of E versus 2P upon R cube. Definitely it will be a curve. So graph will be E against R curve like this. Okay. Hello.
Yeah, sir. Okay.
प्लीज लिख लो ये पूरा इतना so that question you can revise. अभी एक और है इसमें क्वेश्चन. I'm just clearing this, okay? Third question. If this dipole if this dipole is kept in a uniform electric field E naught, diagrammatically represent position of the dipole in stable and unstable equilibrium. Stable and unstable equilibrium. Position of dipole in stable and unstable equilibrium. Stable and unstable equilibrium. And write, not derive, write the expression for the torque acting on the dipole in both the cases. Now first read and just tell me, anybody who is not knowing, then I'm explaining. Draw diagrammatic representation for stable. तो ये stable का हो जाएगा ना, minus q plus q e naught direction and p bar direction is same. This is stable condition. Hello? Hello?
Yes, sir.
What is torque formula in this case? Write the expression for torque acting in this case.
E.
Pardon? Torque will
E sin theta.
तो zero हो जाएगा ना torque.
Yeah. Yes, sir.
Second case में भी torque zero होने वाला है, even in unequilibrium. So this is dipole here. Now ulta, minus q plus q. This is direction of p bar. Now tell what will be the torque here? Pe sine of 180. Again zero or not?
180.
Yes. Sine 180 is what? Zero, no? Hello? Sine 180 is zero.
Yes, sir.
So in both cases, torque will be zero. This was the question asked. अब एक last question है 5 मार्क वाला. First you write down this, then I'm writing the question. So almost some or other method से they have asked electric dipole वाला condition. Either electric field का direction or sometimes direction of torque or sometimes equation. This question can I rub now? Hello?
Yes, sir.
Okay. वापस वही चीज, define torque acting on a dipole of moment p bar placed in uniform electric field E bar. See, they have written bold. Bold means nothing but a vector. Bold मतलब वो लोग ने dark कर दिया ऐसा 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 dark. उसका ही मतलब vector. Express it in vector form. Oh, written also. Express it in vector form and point out the direction along which it acts. फिर बोला है what will happen if the field is non-uniform. If field is not uniform, net force and not net torque both will not be equal to zero. Third, what will happen if the field is increasing Third case, what would happen if external field EV is increasing? First case parallel to P, second case anti-parallel to P. Parallel to P, anti-parallel to P. थर्ड वाला बताता हूं आपको. Define torque acting on a pole placed in, express it in vector form. Define torque, not derive, define torque. Now I'm just clearing this and giving you answer of each. Can I clear the question part at least?
Yes, sir.
Define torque. So first answer, torque is given by tau equals to Pe sine theta. So we'll say it is defined as product of electric dipole, or directly formula if you write then also it is okay. In vector form, tau bar is P bar cross E bar. They want direction. It is always directed perpendicular to plane containing P bar comma E bar. Then if they want what is condition for equilibrium, theta is 0, stable equilibrium. Hello? What will happen if the field is non-uniform? If field is non-uniform, hello?
Yes, sir.
Then you can write if field is not uniform, then torque and force both will be not equal to 0. If field is not uniform, that means we can't get equal opposite forces. Then net force and net torque can never be 0. Then third part, if field is increasing parallel to P, what will happen? This is field E and parallel to P means parallel to this minus Q plus Q. So then force acting on this will be F, force acting on this positive charge F. If field is increasing in the direction of field, then hello? Hello?
Yes, sir.
That means force in the direction of field will increase, in the direction opposite will decrease. So we will say F2 will increase, F1 will decrease because field is increasing on right side. तो right वाला force ज्यादा, left वाला कम हो जाएगा. F2 will increase and F1 will decrease. Okay?
Yes, sir. Understood.
Sir,
Huh?
sir, can you repeat this once?
Which one?
Second question.
Third one, na?
Third.
Third one, A part. This is the increasing field in the direction of dipole moment. So this is negative charge, this is positive charge, this is direction of P bar, and this is E. Okay. So force acting on the positive charge will be right side, negative charge will be on the left side. So can I say right hand side force will increase? So there will be net force in right direction. This is meaning. But if E is increasing anti-parallel, E is increasing anti-parallel to P. Anti-parallel to P means this is positive, and here we have negative charge. This is P. Now this force is increasing. So force on this will be negative charge के लिए I am calling F2. This will be attractive force in the direction of field. F1. Field is increasing but anti-parallel. Hello?
Yes, sir.
Yes, sir.
So anti-parallel मतलब ये वाला ज़्यादा होएगा ना ये. इसका direction वाला ज़्यादा तो F2 will be greater than F1. This is the meaning. So when E is increasing in the direction of field, then net force is right direction. When E is anti-parallel, net force will be in the left direction. This is the meaning. Because right side it is increasing, so this will be increasing because direction of force is ulta or negative. So here increasing field, so here increasing force. Third part is difficult. You all followed the next wala part?
Yes, sir.
So we have completed all the questions asked from electric field wala part from last 10 years. So today we'll stop here. Next class we'll do potential and capacitance. Again all the problems. So Sunday you will write combined test and it will be everybody will keep their video on. I will supervise that. Test timing we'll discuss on Friday. Okay.